I would like to welcome you to the F&A 2024 technical sessions provided by the Metal Treating Institute and the MTI Educational Foundation. Before we introduce the session, I would like to cover a few housekeeping items. First, we would appreciate if everyone would silence their cell phones so as not to distract the presenter and others in class. F&A is officially videoing each session for attendees to view once they have been produced after the conference. We ask everyone to please refrain from taking pictures of PowerPoint slides or videoing the presentation. If we see anyone taking pictures or video during the presentation, we will ask you to please put your camera or phone away. Please be respectful of this request. Lastly, there are QR codes on the walls that go to the survey for each session. Once the session is over, we would appreciate you taking a few moments to complete the brief survey. These help us improve future technical programs. Each session survey you complete enters you into a drawing for a $100 Amazon gift card. Now for our session. Enhancing Vacuum Carburizing Efficiency, a case study of solvent cleaning in airtight degreaser at Mercury Marine. This presentation explores how Mercury Marine, a leading manufacturer of marine propulsion, transitioned from atmospheric carburizing to vacuum carburizing, and how in doing so, it has also replaced aqueous spray washer with solvent cleaning in an airtight degreaser in order to meet the stringent cleanliness standards required for successful vacuum carburizing. Help me welcome your speaker, Mr. Stefan Lukowski.
Thanks, Heather. Thanks, Heather, for the introduction. So yeah, I'm Stefan Lukowski. I'm the cleaning expert. I'm afraid that I'm only the cleaning expert, not the heat treat expert. Normally there was Ranga Kati also meant to be around here. He worked for Mercury Marine, and we bid this whole case study up together. But unfortunately, or fortunately, it depends on the perspective, he got a good offer to retire a bit earlier. So he's not around here today. So I'll cover both parts, the cleaning part about SAFECHEM, the Mercury Marine part. But I'm sure if you have some other technical questions on the heat treat part, then we've got Dennis here from ECM that certainly also can give some more insights about this one. So yeah, we present about enhancing vacuum carburizing efficiency and how Mercury Marine has adopted here a solvent cleaning technology within their new vacuum carburizing line. But why that topic is so important in these days, I want to bring to attention to you what's currently going on here in the United States under the EPA Toxic Substance Control Act. No worries, I will not go through all this little detailed stuff here, but may just highlight on a higher level what's going on. Literally, the EPA is really going after all kind of halogenated solvents at the moment. Be it chlorinated, brominated, fluorinated, everything is right now on the list. With strict regulations where the EPA is looking after certain risk measurements that need to be applied and force manufacturers to also then apply strict rules that end up with really very, very low occupational exposure limits. Talking about trichloroethylene as an example, that will be forbidden with some exemptions from maybe the NASA industry. Methylene chloride is forbidden. PFAS, with the fluorinated solvents, is on the news everywhere. And on polyethylene, there is still a discussion going on, but what the EPA is looking after is like a 0.14 ppm occupational exposure limit at the moment, which is normally not really achievable. So that leads us to the question, is aqueous cleaning the only solution left? And to spoil a bit, I say no, it's not. And that is actually also what the paper will be about. There are a lot of myths outside, a lot of cliches, and my mission today with you guys is to tear down this wall of cliches. So the cliches being around, solvents are dangerous, solvents are harmful to the environment, solvents cause the ozone holes, all solvents are poisonous, solvents will all be banned soon, solvents are flammable, and solvents are very expensive. So again, I will not go into details here right now, but at the end of this paper, I want to have you guys having another mindset set up about what solvents are really about. So let's first talk about a bit facts, about facts. And I'm not a chemist, I need to admit, but this stuff is quite easy also for non-chemists to understand. You have chemical properties that you can utilize on the one hand as they have an advantage in the cleaning application. But obviously, on the other hand, they also mean a risk to either mankind, or the environment. So let's go through that point by point. We have, with solvents, a relatively low boiling point. That means that they have a very good drying behavior, so that you have dry parts, you can clean fast, that's good. But it also evaporates into the air. We have a low surface tension, which is good, so that the solvent can really penetrate complex geometries in parts and get the contamination off, somewhere where it's really almost impossible to get, right? On the other hand, it also means it's penetrating fast into the ground. The chemical is stable, which is good for distillation purpose. You can reuse the product again and again after distillation. But on the other hand, it may be partially persistent, right? And then we have a high solubility of grease, which makes it good for removing consistent or persistent contamination. But it also has a high penetration to penetrate the human skin. And that's it about, when you know what you're talking about and when you have an idea about the characteristics, then you can also manage it. And that's the principle that we apply. Knowing the risk, managing the risk, and if you know about the risk, manage the risk, then you can also profit from the advantages, and still utilize the benefits that these products may have. So this is the agenda for today. We will first talk about cleaning results. We will then talk about worker safety. We'll talk about money, cost efficiency. Then we will get into the case study of Mercury Marine and conclude with a summary. Talking about cleaning first. Obviously, parts cleaning is important in heat treatment. Why is that the case? I think the picture already shows. Dirty parts are not sexy, right? So your customer normally did not order dirty parts when they give them to a heat treatment service. But also technically, in carburizing and nitrating applications, there is an ununiform layer, soft spots, and stop of paint issues. So when you have contamination left on the parts, your results are not good. You can have brazing voids, or what is also important is that if you have contamination left on the parts, even if your heat treatment application in the furnace, if that burns off, then this will contaminate your filters, your pumps, will increase the maintenance costs. Or simply, it will create a lot of smoke, right? So cleaning is important, but why or how does cleaning actually work? And again, I'm non-chemist, I try to always explain the backgrounds a bit offside the molecules and the chemistries as such. We normally use that picture here of polarity showing how a layer of oil is swimming on the water. Yellow and blue. Blue for the water and yellow for the oil, right? And what this means is that this oil will not dissolve in water. And why is that? The oil is a water-insoluble substance, which is called nonpolar. And the water, as a water-soluble substance, is polar. So giving some examples from daily life, if you go to an Italian restaurant and try to mix the oil with the vinegar, will not work, right? Because you have a nonpolar and a polar substance that is not getting into a solution. You got a coffee, not sure if you put sugar inside, but if you bring some sugar inside, then this sugar will dissolve in the coffee because the sugar is a polar substance, right? So that's also what we do when we look into cleaning. We look, what's the contamination? Is it polar? Is it non-polar? Because that brings you actually the cleaning result. And unfortunately, the world is not black and white or yellow and blue. You always have a mixture of different contamination that are on the parts. But if you have oil, waxes, petroleum fats, these are rather non-polar substances that you dissolve better in hydrocarbons, halogenated solvents. Unlike aqueous lubricants, salts would, if you will, also dissolve in a aqueous-based solvent, which is water, right? So that's the cleaning principle. And again, it's not not yellow and blue, yeah, but typically you have a mixture of different kind of contaminations. If you go into the manufacturing process, it might be that you have aqueous lubricants that you utilize to manufacture the parts. And then after heat treatment, you may have quenching oils that are then rather non-polar again. If you're a job shopper, then today you don't know what you will get tomorrow, right? So you need to really have a solution that is also future-proven. And that's also why there is technology available that companies like Hemo is manufacturing, where you have actually one machine that has both. One tank with solvent, another one with water, and then you can clean off the whole variety of contamination that may come in. So that's the theory. Let's also show here some practice. What you can see here on the left-hand side is a picture from non-polar liquid where we put a polar substance in that is not dissolving, unlike here on the right-hand side where you can see how that dissolves. That should again show how the cleaning effect is normally going to happen. And if you want to bring something non-polar into solution in a polar cleaning medium, then you need to add chemistry again to make that work. Yeah? But that is normally a more complex process. Why not start with the easy thing to get things into solution? And that's the way around. If you have heat treatment salts, then obviously that is something you would never dissolve in a solvent. If you have quenching fluids, then normally that's easier to dissolve in a solvent, as an example. So that's it about cleaning results. Let's talk about worker safety. And I'm starting that with a little quiz here. Don't know who wants to volunteer. You. What do you think? Which one of those products, if you read the health hazards, what do you think which product is solvent-based?
I'll probably say the right one.
The right one, okay. What do you think?
I'll say product one.
Product one, okay. That was a good choice because it's the one in the middle, right? What I want to show here is solvents are not always the worst stuff, right? Obviously, solvents can cause skin irritation. They can cause serious eye irritation, but that is also what an aqueous cleaner is doing, because also that is degreasing. And as you can see here, that right one here, I see the right one is German. Huh? I'm sorry for that. It says it's dangerous to water. Yeah? So you have a cleaning agent that is aqueous-based, that is dangerous for water. Yeah? So we are all kind of mindseted by the typical opinions that water is green. But what you need to consider is, if you clean with water, you're not cleaning with water normally, but you add chemistry into the water, and that needs to be treated after you use it for cleaning, right? So also that is a typical picture that people have in mind when they think about solvent cleaning. That's by the way when Andreas, when he was a little bit younger and he was operating here, then one of these open top degreasers. But that's not what solvent cleaning is about nowadays. Yeah? That is how solvent cleaning looks today. In a closed machine, again that is here an example of a Hemo degreaser in here, there are no emissions, virtually no emissions. Some little, but definitely not like on the left-hand picture and what everyone thinks about when they have a solvent-based cleaning machine in mind. And that system works differently to the old technology where you don't bring the parts to the solvent, but actually you bring the solvent to the parts. You have a cleaning chamber, which is getting closed, and only at that moment, then you apply the different cleaning steps. With a first wash, some mechanics to remove also particles. You have filter systems included in the machine that will filter out then the particles. You may have a second wash here for the rinsing part that, again, if needed, can also be done aqueous. You don't have to do it in 2 solvent steps, but depending on the contamination, can also build in here an aqueous-based cleaning tank. And then you have still a very little layer of oil normally left on the parts, because this cleaning quality is always only as good as the last tank has been contaminated with contamination, and you cannot always have it at 100% clean. So what you would typically do is that you then bring the solvent into vapor phase, and you blow that hot solvent vapor into the cleaning chamber, where then the solvent condenses on the parts and rinses off really the last layers of oil that might be there, which really gives you like the premium or high precision degreasing results. And then afterwards, you dry the chamber, right? Only when the solvent is off from the parts, it would open up again and you get out cleaned and dried parts. Good. So, cleaning results, worker safety. Now let's talk about money, cost efficiency. Why is solvent cleaning also cost efficient? We did a study in the European Union where we collected some data back in 2006, where we have captured how much solvent would you require to clean off 100 pounds of oil. And back again, remembering how Andreas looked like at the open top degreaser, this kind of technology that is consuming an equivalent of 750 pounds of solvent per 100 pound of oil, just because the vast majority is really air emissions, right? If you close that technology, then you can already reduce that one significantly down to 10 pounds per 100 pounds of oil. And if you then apply what we call chemical product services, CPS, like monitoring tools to test the solvent, stabilize the solvent to bring it back to the virgin quality again, then you can reuse the solvent in the machine again and again and further reduce the consumption to only 15 pounds per 100 pounds of oil being removed. So that's an official case study available from the European Union. We do also have some own customer examples where we could even reduce it further with on-site consultancy to an equivalent of 4 pounds of solvent used per 100 pound of oil. And that is a reduction compared to the previous technology in the old days of 99.5%. And that's really something that you don't find a lot in the industry when you talk about sustainability, environmental friendliness, and chemical consumption, and how to reduce costs. So another important factor, obviously more important in Germany than in the US, I have to admit, but energy prices, right? Whatever the cost is, but a very important or good indicator here is the energy that is required to bring the fluid from a liquid phase into a vaporized phase, and how to dry parts off. Here you can see that solvents typically have a much lower factor required here to dry off compared to water. And to let some pictures speak here, that's not Dennis and Andreas with a straw behind the glasses. That is a heating plate. And here you can see on the left-hand side solvent compared to the right side water. So we've got chlorinated solvents, left perchlorethylene, in the middle there is modified alcohol, and then you can see the water. So solvents are really evaporating much faster with lower energy being used, which saves you a lot of energy cost. Good. So that's been the cleaning part, my area of expertise. Let's see if I can also cover Ranger's part now on Mercury Marine by giving you now an example about what Mercury has done in regards to parts cleaning. That is a case study that we have developed here together with them. So obviously Mercury Marine is a quite known brand in the market, manufacturing propulsion systems, headquartered in Fond du Lac in Wisconsin, a subsidiary of Brunswick Corporation, and manufacturing and distributing engine services, parts for recreational, commercial, and governmental marine applications. What Mercury Marine has, they have an in-house heat treatment facility where they heat treat the parts that they manufacture, gear case parts, propeller shafts, gears, clutches, and in this process they have machining involved. Machining that can be done dry, but also requiring a lot of lubricants and oils in the manufacturing process for the turning and the milling applications. And from all the parts that they manufacture, they have identified 170 parts that need to be cleaned before they get heat treated. And what their mission was actually, and that's also here openly, transparent speaking, not been a quality issue that they were working on. They have been working on more environmental issue to say, we want to get our company become more clean. We want to convert from atmospheric carburizing applications to vacuum carburizing. And in this context, then have made a strategic decision in 2023 to work off that whole manufacturing line. As they said, that with all the smoke and the environmental impact from the evaporating oils in the factory, that's nothing that they want to work on. They had an aqueous cleaning line integrated in the atmospheric carburizing process, and that also occasionally led to some quality issues, but the main reason really was to go to that vacuum application to become more clean. That's been the main driver to move on. And the challenge was that if you want to go vacuum, then it's not only to be more clean for the outside, you also need to be more clean inside, if you will. As if you apply vacuum furnaces and you bring not good clean parts inside, then these contamination, as already highlighted earlier on, they can create issues in your filter systems, in the vacuum pumps, and thereby also dramatically increase maintenance costs. Another issue or challenge that they've had was that they wanted to streamline the overall process to become more automated. And one of the solutions was to apply here carbon fiber composite loadings and fixtures. As their idea was, I can utilize that basket in the cleaning before heat treatment. I can use the same basket then also for the heat treatment application and for the cleaning afterwards. And as we know, normally CFC fixtures and baskets have a higher price compared to the regular ones, but that automated process with less handling, that was jeopardizing this increased cost. However, these fixtures and trays, they are like a sponge, right? And if you load them up with oil, it will take it on, and then it needs to be properly cleaned and get in. But more importantly also, if you bring water in, then also this water can create moisture in the vacuum furnace, and that's also something you don't want to have in. So in this context, aqueous cleaning was something considered rather critical to do before the heat treatment application. And then this smart guy, Dennis, came up with the idea, hey, well, someone of his team, obviously, as I understand, but they came up with the idea to say, okay, we will come up with a complete concept, a full line out of a solvent-based degreaser, together then with a furnace from ECM afterwards, where the solvent degreaser is seamlessly integrated into it, so it can take the basket as is in the cleaning machine and then getting transferred directly into the furnace afterwards, so that there is no movement of parts between these steps. You can really take it from one step into another. And the airtight degreaser manufactured by Hemo, that is really having literally no emissions, and that also made then the environment safe. So the solvent cleaning was chosen mainly because of that CFC issue, and that no water should get in here. And the benefit and the beauty really about the solvent-based system is that you don't create here any wastewater and really have a very, very low profile of chemical consumption. In the machine, you have a distillation integrated. So by temperature, you can always separate the oil from the solvent again, reuse the solvent again and again. And talking about a couple of numbers, the machine is in installation since sometime last year. Until now, no bath exchange has happened. 95% of the solvent could have been reused since. There is only very little top-up volume, and only occasionally, once in a week, a test needs to be done on the solvent, how the quality of the solvent is, and then occasionally you may add a little gallons of stabilizer to improve the solvent quality, and that's it. Simple as that. So vacuum carburizing, supported by inline solvent cleaning, offers here a superior quality. You get a more clean environment, generally speaking, and also increasing results. Bottom line, the vacuum degreasers are a very cost-effective solution, also increasing the EH&S standards. and you have no water and no wastewater treatment required in that overall process. That also makes it safe and sustainable. Right, so we are almost at the end, and I have reserved afterwards still some time for you guys to raise a couple of questions. But in summary, let's look into the wall of cliches again and how to tear down that wall of cliches. So, solvents are dangerous. That's right. Yeah? Solvents have hazards that you need to consider, but if you know about them and you know how to react on this one, then you can control the risk, manage the risk, and still benefit from the solution. Solvents are harmful to the environment, but if you use them in suitable or good technology, then also you can make use of them accordingly. There are a few solvents that indeed cause ozone holes, but these are all already banned from those that are still available on the list. Don't believe everything that you hear, but make an educated research and look into that. That's not always true. Not all solvents are poisonous. So you have different profiles, as we have seen here also on that one MSDS, that sometimes some solvents are less harmful than an aqueous-based cleaner. Obviously, there are some solvent-based cleaners that are poisonous, but then again, in a closed machine, you respect the occupational exposure limits, and normally it doesn't matter what kind of solvent is in the machine because you're not exposed to the chemical as such. Not all solvents will be banned. So we could talk another hour about which solvents will be banned and which ones not, but just keep it as is right now, that this is something that is also not really true. Solvents are flammable. That's also correct. Not all solvents are flammable, but that's then the thing that you need to play with. If you have a flammable solvent that is normally not halogenated, if you have a halogenated solvent, then you have a more poisonous solvent. So you need to balance what you want to have. Something poisonous or flammable. Again, in a closed machine, when you manage the risk, it doesn't matter because you can manage the flammability, like you can manage also that a solvent might be poisonous at too high occupation exposure limits. And then solvents are expensive. Also correct, depending on what kind of solvent you look into, then the kilogram or pound or gallon price of a solvent may be expensive. But if you don't have any consumptions in the application, in the process, it's definitely cost efficient, regardless of the price. So that's my summary. If you have any more detailed questions or topics you wanted to dive into, then we don't have a booth here, I'm afraid. But HEMO has a booth here in the trade show. ECM has a booth here in the trade show where you can probably go into real deep discussions. Other than that, I'm here for, I think, Heather, another 5 minutes or so to answer the questions that you may have out of that paper.
You said after a year you only lost 5% of the initial chemical?
Mm-hmm. Thank you. To put it in perspective, a machine has something like 1,000 to 2,000 gallons of filling volume normally. So that's when you think 5% of that is then the consumption of the machine. That's indeed impressive. And people ask us how we are able to operate with our company. I always say that we are working as a charity. We do that all free of charge. Any other questions? Dennis?
The equipment interface with other companies and working together with customers. How does that work? Is it through HEMO and SAFECHEM, or how would that work for customers?
So on the machine part of things, that would definitely be HEMO. So we are not the a technology specialist. That's really HEMO's part. But I think Andreas, you may be able also to give a few comments on how the machines are normally designed in heat treatment applications, having always the right basket sizes for the corresponding furnace. If you want, we have 5 minutes left, so if Heather allows, then you can also make a comment on this one if you want.
I mean, it's quite easy. You got a batch size, and if you want to have this batch size,
as the degreaser as well. Yeah, we can build that no matter which size, even if it's 48, 36, 48 or bigger. Yes, we can build the same application, so you never have to load and unload the batches. Yeah, so you can do it from the beginning till the end. And using a communication processor, you're always able to communicate with the heat treatment line. Doesn't matter what kind of system it is.
So what HEMO really did is they have specialized on something which is now a standard to them, right?
Yeah.
So in this, it looks like it's largely a pre-cleaning application because you're gas quenching and so on. And it's, by the way, good presentation. But the question is, I guess more and more for HEMO, are there quite different setups for cleaning? You know, if you wanted to use one of these for post-cleaning in an oil quench situation, what dynamics change as far as, you know, the ratio of solvents used and recovered in an oil quench situation? And does the machine change much if you're going to use it for pre-cleaning or post-cleaning because the contaminants and the loading is so different?
The machines change a little bit because you got much more oil after the oil quenching process. So we invent a pre-spray process. So this means we use a couple of gallons of the solvent and we spray it on the batch. With that, we reduce almost 80 to 85% of the oil, and we take it directly into an evaporator to evaporate it.
You pre-spray before you...
And it doesn't go back into the tank, so you don't contaminate the tank. It goes to the evaporator and it's going to be evaporated directly.
Is all of the solvent thermally, you know,
At any time, 100%.
But you have, so you really add a second evaporation system dedicated to treating the initial spray of the solvent.
Yep.
That carries the heavy load of the oil. And can that oil be then reintroduced? Is it clean enough to be reintroduced?
No, not possible.
Okay.
Yeah, but especially with the quenching oil, with all the additives it has, some special characteristics, and you always have like 5 to 10% solvent in it. You cannot use it in the quenching part again.
So in a post-cleaning, you still have the carry out of the oil ends up waste.
Yeah, it's going to be
But
waste.
you don't have all the homogenized crap that you get with that bad idea.
You need to recover before. Yeah, I know some commercial heat treaters. Yeah, they try to do it in a centrifugal way. Yeah, just to recover a little bit of the quenching oil and take it back. Yeah, but you cannot bring back 100% since it will be always contaminated.
So in that case, you have say a common washer that you could use for pre-wash, but if you used it for post-wash, really you would add this extra distillation system and just have a different cycle.
Yep.
And so is that like an option to somebody that's post-washing with oil?
It's an option. Yeah. It can also be ridiculous. Yeah. But you can use the same machine for pre-cleaning and for post-cleaning.
And aqueous
And aqueous and solvent in one machine. That's the so-called hybrid system. Yeah. And you can only choose, for example, for the post-cleaning, you only use the solvent part, you don't use the water-based part. For the pre-cleaning, you use both. And you get different kinds of combination. So it's really flexible system.
And if you had that heavy oil again for an oil quench, you would still advocate using solvent to clean the oil and just have the additional separation.
Yeah, that's it.
In the interest of time, our speakers and their associates will be available post-session and at their booth. Thank you so much for attending, and please give a round of applause to our speakers.
Thank you.